Thanks, Daniel, for the introduction. So yes, since I was very well introduced, I won't repeat what Daniel just said. But about 2 years ago, before I came here, I started to write this proof of concept of integrating some libraries, OpenRTP and MediaStreamer 2, into a Kamailio module, so that Kamailio could be also an RTP endpoint and do some media processing features. So I will explain a little bit. There was a lot of resistance, of course, to this proposal, but so I will try to cover many points in this presentation. I will discuss about why I think it's a good option and it's a good idea to do that, integrate these media features inside Kamailio. Then I'll speak more about some of the problems people were of course worried about some problems with threading and multi-processes. And other performance, I was some kind of initial questioning about will this be performant. Then I will explain how we can use this module and what can we do with this module right now. And because this module is not a standard module, we don't expect it to be built with Kamailio when it's shipped. So I will explain how to install it. Using Docker, I also created a Docker file that does all the compile command to build on the Debian, a working version. Some of these libraries used are shipped and packaged on Debian, but they may be challenging to align sometimes. So at least there is a reference to a working solution. And then I'll end up making sure I'm sharing a clear state of this module. Is it safe to use in production? I mean, there's lots of work to be done. I don't want to give the wrong impression. So yeah, initially, like 2 years ago when I was just discussing this, I was very few people were thinking this would be a good idea. So there was many discussions, few discussions at least. And in the end, there was no philosophical objections, but I'm just mentioning that. So Kamailio is a SIP proxy. Why would you do media processing in a SIP proxy? Yeah, in this case, it will not be a SIP proxy. I will because I don't think it's doable. But the way I see Kamailio, it's not just a SIP proxy. It's more a SIP stack, configurable SIP stack that is mainly a SIP proxy. But there is so many features around it, so that when you start to use it and know how it works, in the end, you're learning a lot of things, and there may be synergy with using Kamailio to host another library that could do other things. So what do I get from Kamailio? I get the SIP stack, the scripting engine also. It's not something that easy to do, right? Some of the other PBX, they have like customs. They embed scripting languages, or they have scripting languages, but Kamailio has one, and there is lots of work being done in integrating scripting languages like Lua and Python, and yes, all these features in all the modules. So Kamailio, I think it's more than 15 years of development, right? I remember when I first heard about it in 2000 something. I'm not sure about the exact date. There's more information about that can be found. And then the other part that I'm combining is OpenRTP and MediaStreamer 2. Most people will know these libraries as being part of LintPhone, but historically they were not developed for, OpenRTP was not developed to be used exclusively in LintPhone. HP was founding the project for their OCM media server. But ORTP is only RTP, it's not media. But anyway, I got some information from Belden. But mentioning Belden Communications, they are not involved in this module at all. I don't want to give the wrong impression here. I'm just using their libraries. So MediaStreamer 2, I worked a lot with it, and I found it very, very well simple and very well designed, because it's implementing like a graph of filters, of audio filters. So it's well structured compared to some people may say, I don't need this kind of architecture. I will just take the sample and put them in a buffer and share them. But in this era, I think there was also GStreamer. People were thinking we need to have a well-defined audio graph. So that's what MediaStreamer 2 is doing in a simple way, I find. And even if it's in C, it's kind of super high level. It's doing many things automatically. There is factory programming patterns, so you just instantiate the factory, and then you have all your codecs and your stuff ready to be used. So yeah, in the end, it's combining these two projects. The other project is like 20 years old, I think. It was the first SIP phone on Linux, Linphone. So my strategy is to say, I know both of these projects very well. I know the source code, so I think there is a lot of value in combining these two softwares. So then people will also think, why would I reduce, I use Kamailio and suddenly it will become less performant, it's not designed to do high CPS. Well, in the end, it doesn't mean that the same Kamailio will be doing the same role it was doing. Like in IMS, you can see they have different roles for SIP proxies. So here I'm sharing at Florout, for example, we have at least 3 kinds of SIP proxies behaving a little bit differently. Business logic is in the core. So this is just a very simplified example, but it's kind of showing that we have 3 layers of proxies with different roles, like the registrar role, the edge proxy. Maybe in the past it was more about NAT traversal. Now it can be multi-device or doing extra work and publicly exposed. So this is a common thing to do. People will say, hey, I can run everything on one Kamailio, so let's do 2 Kamailio, HA, and then I'm good. Yeah, of course it's not a scalability issue, but it's maybe more a stability issue. You don't want all the same features exposed. Maybe there may be many, many reasons. So in the end, when you use this module with Kamailio, you end up having Kamailio as an application server suddenly. And you get most of the features. Not all of them will be compatible, of course. And you get, of course, you get what Kamailio is already very good at, is receiving and sending SIP messages. And it's also doing a little bit of SDP, but there was, of course, not all the features required here in Kamailio. So we'll cover this a little bit, what I found. And then you have the scripting engine, as I said. So I think it can be another solution to do with open source free software to do all kind of things. All these libraries were designed to be embedded, like all in C. Even C++ was not used because at that time I think embedding C++ was challenging. Or anyway, they should be easy. Beldon, some of their libraries can run in a very small doorbell, for example. That's one of their use case. But now maybe embedded softwares have changed and now there's less requirement. So what about, the fact that we have this multi-process application using a library that is creating many threads? Initially I said, oh, no problem, because these libraries, they expose a wrapper around the malloc and free, like the way you allocate and free memory. So in this case, you could say, oh, whatever happens, these threads will use shared memory. So I don't have to worry about that. But after facing 1 or 2 little problems that could probably easily be fixed, but for some weird reason, one of the library was not using the wrapper, even if it should. I didn't troubleshoot it. I'm sure it's a little thing that they could fix. But I think it's risky that suddenly you have more edgy problems inside the library, bypassing the wrapper and then allocating unsafe memory. So what I did is I decided it was not necessary after all. It's better to deal with use shared memory only to interact between call state change and the workers, all of the other Kamailio processes. Here I'm just mentioning the UDP workers, but you have also the TCP ones and other. So only one process will be enough. So right now I'm just thinking, I'm just proposing to use only one. I don't suspect there will be a bottleneck in using only one because everything should be asynchronous by design in the main loop managing the. Maybe it's not that true, so maybe there will be some need to do more than that. So I mentioned that MediaStreamer was using a graph of filters. Here I have a little example of when you bridge a call. So the call, they are bidirectional. One receive is connected to one transmit, and vice versa. So this is one graph. where here we have the RTP receive filter is called MSRTP, Media Streamer RTP RECV. So in the end, I'm just calling it RTP RX here. They also provide a jitter buffer in the coded domain. So there is an adaptive jitter buffer that can be configured. They have at least 2 algorithms or 3, and one of them was refactored like 2 years ago. I think it's using a Kalman filter, a predictor. They're quite satisfied with it, apparently. So there, here we can see so this is OpenRTP inside this filter in the end, running the endpoint, and it will open the socket and receive them. And it will pass all the samples to the decoder, the packet to the decoder. They have a way to share packet, an efficient way to share a packet between filters as well. So this is kind of weird. It's not an audio filter, but anyway, to be compatible, it is. And then the decoder can also, to use, let's say, forward error correction from Opus. Their jitter buffer is already compatible with that. So at this point, we really have samples. So the samples are passed. If you need a resampler, you use one. The samples are passed, and then they are packetized and sent. So because you're using this graph, you can also have good monitoring on every single filter. So you can have statistics of which filter is wasting your CPU. So it's just an estimate of CPU time, the percentage of time that was spent in this filter inside the graph. And then you have more statistics. So it's a very feature-rich library. So in the end, but using a SIP proxy, it was not possible, I believe, to do all of this because a SIP proxy is supposed to relay proxy messages. It's not supposed to terminate them. And but in Kamailio, there is already some features to do. There's a UAC that can be used. So I don't think there was no need to rewrite everything. So this is the transaction module. This is C code. So it's just to show that these functions are being used in many modules. I've seen them in, I searched many modules to find who was doing what. So I looked at music on hold. It was doing some of it, this music on hold module. But music on hold will use a refer in the end to redirect the call. So not all the soft phone will be compatible. I mean, some of them will find it unsafe to redirect the call. Anyway, so you can see the TM module as an API. So you load the API. It's a set of functions that you can now use. So you can say, hey, create a new dialog, UAC. And then there's tons of parameters, so it's quite configurable. You can add headers and configure many things. And then you say, send this request within the dialog. And on the server side, that's really more common. You reply, you just transaction stateful reply. So yeah, many features were already available to do UAC, UAS in the end. So what's really missing is the state of the dialog. I mean, there may be other things missing that I didn't find. But in the end, what is really missing is the state. And the dialog module is not really about saving dialog compatible state. So it didn't seem very useful in this case. So in the end, this module, the RMS module, will have to maintain the state of the dialog, and that's mainly what it does, maintaining the state of the dialogues and driving ORTP and media streamer. So early on, when I started having to have this idea, I questioned myself about OpenRTP and media streamer too. And as I said before, HP was using it, and I was told that that they can handle 2,000 calls at that time far in the past. And that Media Streamer 2 was not a server-side component, but yes, recently it became. And they did fix a few issues, and now they say it's stable, and the message block, the way they were sharing message, there was, they found at least 2 issues that were fixed, and they're quite satisfied with using this on the server side. Then the DRMS module itself, it shouldn't be that hard to scale as long as there is nothing blocking in the main loop, which should not be the case by design. But anyway, there may be a concern here. It was not tested. But I don't think, in the end, I have some kind of fictive scenario to try to see what kind of benchmark could be acceptable, and to highlight the fact that call per second is never really, is rarely the bottleneck on this kind of server, like, because the main bottleneck should be expected to be in the encoder, the resamplers. But if it's only relaying packet, then maybe that's not also the best option. But yeah, even relaying packet, I mean, it should be very fast at relaying packet. So yeah, let's look at one or two examples of what you can do with this module right now. What kind of feature were implemented. So this is an example where you play a file. So the main route is here. So you say is to tag. As to tag means is it an initial invite? That's the trick. So you say yes, it's an initial invite. I will create a dialog and everything. So I'm telling RTP media server answer this call and go call the block RMS start. And then the RMS start will play a file. There may need to use a resampler or not. This will be already detected and supported. And then you can see that you can kind of start to have some kind of IVR features here where you can say, hey, after you play the file, go to another route block. And in this case, simply hang up the call. So yeah, internally in Media Streamer, maybe it's some, in my scenario, I was using CSIP sample or LinPhone on an Android. We can see what's going on inside the RMS module kind of architecture. We see that the caller is considered like a leg, call leg, and in this case, I call it the A leg. And we create this chain of, we spin up a ticker, and we create this graph. There is two graphs. In this side, we need to take care of transmit and receive. So the receiving graph, we just say, okay, yeah, be compliant, spin up an endpoint, receive the packet, and just get rid of them as lightly as possible. We're not recording. And the sending graph, we are saying create a file player, then optionally link a resampler in case we need it, and then it will be configured later. Link the encoder based on the payload type that was detected, and then send spin up an RTP endpoint to send an RTP session right inside an endpoint, and then send the packet in a compliant way. So yeah, you can already play file this way. Now you can also bridge calls. So in this case, it's same thing, same technique, and then you can have the target can be a variable. Must be a valid SIP URI, very sensitive here, and there's not enough sanity checks, I think, maybe. And then again, you have a callback function, a route block, and it will be called on success. Yeah, I'm not sure about the on failure in this case. At the end of the bridge, either it fails or it starts. That's where there is a lack of flexibility, very most evidently here. So more commands, maybe an asynchronous sleep could be used, because these event routes, they're not, the way Kamailio uses them is creating a fake message, a fake SIP message, and then he can call them whenever he wants. They're not related to really a real network event receiving something or. So in the end, you could do an asynchronous sleep easily and call the routing block later. And then without DTMF support, you can do much, I think, in terms of. So what's going on in this case inside the module, the media streamer module part, I'm focusing on. The other one is more, is less easier to configure, in my opinion. So in this case, we have two call legs, and they are separate. They are stored separately in memory. They are. Each of them, they have a call leg media as well. They are a dialogue. They are called a dialogue information structure, and it does contain one call leg media. And you can see how they are bridged using a CSIP sample, again, in most of my tests, and a VoIP patrol server using PGSIP, everything SIP compliant. And you can briefly see the transmit stream finding its way. And you can see that, and the receive stream finding the way on the other direction. And you can see how easy it is to use media streamer, how high level it is. You start a ticker. The ticker is like, it will spin up a thread, and the ticker will be responsible for executing one or more graph. So every 10 milliseconds, it will take the graph and it will execute, give a chance to each filter to execute. Some of them may say, I don't have anything to do, but they will be synchronized in every 10 milliseconds. And then, so what you do is you create this ticker, then you attach you start the connection helper, an helper function to simplify things, and then you can attach your filters easily to them. So here we have two graphs, and then we attach multiple graphs to the ticker. And here we go, we have the media streamer every 10 milliseconds will run all of this in one thread. And then I also added bridging after playing just to make sure it's easy to keep these call legs structure so you can detach them and reattach them. There was enough, the architecture was not broken in this way. So in the end, it's the same test, but this time what we do is we start by playing and then we bridge. So to prove that first we did answer the call and create a media chain where we connect a file, and then we completely destroy the ticker and the chain, and we create a new one, a bridging chain. So in the end, the dialog doesn't care that much about everything can be destroyed and recreated, like the codec can be changed. You know, when you have a reinvite, as an example, you may only need to change the encoder and the decoder. You may need to change part of the audio chain. This is also where this audio chain graph is kind of easy to follow, maybe a little bit more, because it's well structured, so it's not too challenging to understand the state of it and how to modify it. It's not like tightly coupled to your to larger C source code files. Yeah, so what was really missing is the SDP parsing, because there was no need for Kamailio to do most of this. So this part is kind of weak right now, but so I use the parsing that was available in Kamailio. And then I added some basic functionality. And I did make it work with Opus, but it was very unsafe and unstable because the code was just some kind of in a hacky state. But I think it can be, of course, it's about parsing SDP. It can be done correctly, and but just if you test this server, you can only use PCMU, PCMA, else it will say incompatible codec. It won't. But in the end, the good news is all of these codecs are well supported in MediaStreamer 2. The only reason why they are not there, it's because of the SDP parsing. Like Belgian Communication, I think they rewrote the G7 to 9 codec completely from scratch. I think it's it may be the only version that is really open source. The other ones, I think they are used from Intel source code or. So, I mean, there is plenty of codecs implementation in the MediaStreamer 2. And they are, most of them are very well integrated. Like the Opus one, I know it very well, and it's really doing the right thing with forward error correction, PLC, everything. Because I think it may be challenging to test this module, so I did take the time to create some Docker files where you can, in the end, find exactly the commands I'm using in my lab to create it in case there is incompatibility with the libraries. They have lots of libraries, and they evolve really quickly. So, yeah, you have inside the module in Kamailio, you will find a Docker file with all the commands to build on Debian. And you can just create an image using a simple Docker command. Then the configuration part, I didn't do exactly what was right, so it's mainly not using any templating. You need to edit it manually right now. Because I had some issue with listening on 000. I don't know if it's a Docker problem or if it was just my image. But I mean, I'm just proposing, I guess adding Docker template, using Docker template, it will be better to use the env variables and configure Kamailio automatically, maybe detect the IP address automatically or specify it at Docker run. Yeah, I also provide a little script on how to start it in an interactive mode, which is not making much sense. But when you troubleshoot or debug, I think it's better. It may be more convenient to start it. So you start it manually from inside the container, so you can just stop it or start it without restart. It's not a good practice in Docker, but in this case, in a lab, I think it's probably more convenient. Yes, so I think I need to be clear on the state of this module. All the features, even all the minimal features required, are not implemented. Like early media is not recreating the. Early media will not play. So there is a little bit of work here, and yeah, DSDP parsing is far from being complete. And without recording or DTMF detection, that shouldn't be too challenging to implement also, because of media streamer is designed to call callback functions automatically and do everything. So there is no low-level programming. It's mainly a better integration into the scripting engine. And I'm expecting many problems because there was not enough test and. But I think what's the most important thing to do would be to integrate automated testing in the. And in this case, it cannot be part of the normal Kamailio test. So I will most likely include what you need to test the module using Python Behave and Docker Compose. So to easily rerun the test every time there's a modification to find regressions and easily. Yeah. So I'm not sure if my timing was very good or if I was too fast, but yeah. If you have any question, you can ask me. And okay.
Okay.
Or comments, or maybe.
I see here a couple of many. So 1, 4. So probably we'll take 2 or 3. Okay, you and maybe you I have seen, but I see also maybe if you are fast, we take all of them. But Daniel, please go on. Maybe you can just go in the middle, and we'll let Daniel to set up.
Okay.
Yeah.
Because they're a bit behind, and maybe people.
I just noticed on the Kamailio script that you've been using the function that is handling the rest of the call for you. So don't you think that's losing of flexibility? So what to do in the case of in-call signaling?
Oh yeah. So I forgot to show you this part. I think there is what you do is you say RMS dialog check. Have you seen this one?
Yes,
so
yes.
Okay, you saw this one. Yeah.
So all of the rest of the call is covered by this function.
Right.
There is no flexibility, for example, I don't know, separate process by, separate process read bytes, and the call separate process, like subscribe, notified, all of this stuff.
Yeah. I mean, notify is not covered by this module right now. There's no presence functionality. It could be added, but I don't think it was a core feature. So mainly it's about invite and
invite by
yeah.
What else? Re-invites, reestablish media sessions. So some of these type of the functionality.
Yeah. Okay. So you're saying there is probably a lack of flexibility with handling these functions. Yeah, most likely. But at least it will do the default behavior properly. Normally, when you receive a buy, what kind of decision could you take? I mean, you need to disconnect the column, but I mean, all of this is open.
For example, I don't know, just set up the HTTP query to some other service like a billing, like the billing, or also.
In this case, it's using the transaction module, so you could use the callback function. I mean, it's not been tested, but you get the buy, so you could say, hey, I have the buy, or you can get the reply also. So you're saying that the reply route may not be set properly, the standard features.
Replies,
yeah?
I don't know. Means
I think it will work, but it was not tested. But
okay, maybe you can discuss more about that to take another question. Okay, Valentin, then I see there, but
just
be
a
fast.
question about the big picture. Do you intend to have this module for something like conferencing, or is it just thought for simple use cases?
The intents are not clear. But I know conferencing is possible with MediaStreamer because there is other conferencing server built with MediaStreamer. It's not part of the minimal feature set I am proposing, but I mean, if it's something that is making sense for people, I think it's doable, but it will require work, and
So
there will be features required and all kind of things. But
it's one behind. Okay, so yeah, the idea was to push it there and see the interest, and based on that, if people contribute or some other people have time, then we'll see where it goes. Okay, there, and maybe you can put your laptop now.
Yeah, I think this could be a good use case. I've kind of got an extreme scenario. I have to do 200 calls per second and get up to 20,000 concurrent calls, kind of all the way up. Do you think a cluster of, and all we're doing is playing one WAV file. So it's all the outbound notifications for a very large US utility. Do you think a cluster of Kamailio 8 to 10 servers could handle the 200 calls per second and the 20,000 concurrent audio streams?
20,000, you're saying? And
Yeah.
10 servers? Yeah,
Well, I mean, I don't know how many servers,
but
but
these numbers
like,
are making sense. But of course, this is not load tested yet, so I'm expecting it will probably fail initially. But yeah, theoretically, I don't see why. As OpenRTP is known to be capable of handling 2,000 calls on a server, and on all servers. And MediaStreamer too, yeah, I mean, it's being used. And in the end, I really suspect, because I've used it a lot, that, for example, the Opus encoder will take most of your CPU time, depending on the complexity, or a bad resampling. So let's say without resampling, just playing a file, maybe, I think you can, I'm quite sure this can be done, what you're describing here. Like,
yeah, I mean, right now we've just written our own SIP stack and Node and RTP, and we just do it off a whole bunch of Node apps. But, you know, ultimately I'd like to get to something a bit more supported.
Okay, we'll see in the future, but yeah, it's a good maybe collaboration between you and Julien to discuss and see how it's going. And the last one, hopefully very short, and yeah, the last one there, very short, thank you. Maybe you can put the laptop, if they ask you, show them afterwards,
Hey.
because we are a bit late.
I'd like to ask about the handshaking for the SDP for initiating the RTP. Are you doing encryption like DTLS and the like?
no, I am not. The OpenRTP does support it, though. So I think there may be a limited amount of work to be done, but I'm not going to.
And what do you do if your handshaking as it is now fails in your scripting, so you can't bridge?
So if the encryption handshake fails, yeah, it will just fail badly. No, it won't be. No, this was not tested.
Anyhow, I see it's a lot of interest in it, at least curiosity from that point of view. So I'm sure Julien will have interesting chats with you. So approach Julien, and of course provide feedback, because we are a community. So whenever is some new addition, it's important that people say, hey, looks interested, I would like to test, help with feedback, documentation, and so on. So we are a bit late. Thank you, Julien.